Hello everyone. Today we are going to discuss about different layers present in a network. There are 5 layers in any network or a model. So it's the physical layer at the bottom, data link layer, and then comes the network, transport layer, and the application layer. The user sits at the application layer. Let us take an example of a mail. So if a user want to send a mail, uh, they use an application to send it like Gmail or Yahoo. So user is usually at the application layer. The data in any layer is represented in these forms. Like at the physical layer, the data is in the form of bits. At the data link layer, it's in the form of frames. At network layer, it's in the form of packets. At transport layer, it's in the form of segments. And at application layer, it's the original message. So if the user is sending a message, so it goes down. It goes down from the application layer to the physical layer. And let us say, suppose the message is MSG. So this is the original message from the application layer. And when it reaches the transport layer, there's an header attached to the original message. So it will be message plus H4 because it's in the fourth layer. I'm using H4. And at the next stage, H3, the header H3 is appended at the third layer. So it will be message plus H4 plus H3. So it continues till the first layer. So this header is actually attached to every message because it has the information of the IP address of both the sender and the receiver. To transfer the bits and segments or the packets, whatever used in every stage, there is always a need of a channel or a medium. It could be like any wire, cable, or air, etc. So let us look at the channels used and how the signal is transported. So Fourier analysis or the Fourier transform is used to analyze any signal. A signal can be measured using the summation of its components or the building blocks. So here we can, so this Fourier analysis can be explained using an example. Let me take an example of the sine wave. So this is the sine wave, and the human sound wave is also measured using the sine wave, like its form is in the sine wave. So this from here till here, the whole wave is considered to be like one cycle. And let us take this as time on the x-axis. So if like there are multiple cycles happening, we can say that there are 2 cycles between this time interval. So when it's converted to the frequency, it's like for the first wave, the frequency is calculated in the form of hertz, so it will be 1 hertz. And for the second wave, frequency is calculated in the form of hertz, and it will be like 2 waves, so it will be 2 hertz. And for a human sound wave, the frequency is calculated like 3000 hertz. So the thing is, a Fourier transform allows us to build signal into frequencies. Like the signal here in the form of waves, we are converting them into frequencies, and this is done using the Fourier transform. These frequencies are also called as harmonics, and these harmonics are measured on the graph. Like, let's see in the next slides. So this is the harmonic number. So here we can say there's only one wave, so it's like one harmonic. Here we have two waves, like from here is one, and from here it's the other one. So it's called like two harmonics. And this graph shows like there are four waves, so it's like four harmonics.